G'day and welcome to day 2 of the Start Creating Robots challenge course, and this is the autonomous navigation course. So let's get into it. So what do we mean by autonomous navigation? Well, it's actually a reasonably difficult challenge. You've got to put a person in a room and say, hey, go find the kitchen or, walk around and don't run into things. It's pretty basic stuff that, anyone over the age of 5 is going to, have no trouble with. But when a robot needs to do this, there's a lot of algorithms and complexity that needs to go on. And if you're building a robot from scratch, you'll need to provide the robot with the ability to be able to sense its environment, work out where it is in that environment, and then path plans around that environment and avoid obstacles. And so rather than actually doing all of that yourself and trying to get into the details, what we can do is we can use the ROS operating system as a way of taking advantage of other people's work to do these things for us. Good day. Okay, so here we are inside of our web browser at localhost port 6080, just after having run the Docker command. So let's double click on VS Codium and open it up. And you may find that you need to open that same folder again, which was at home, and start creating, oops, I got it wrong, start creating robots, hit select, away we go. So now what we're going to do is we're going to look at autonomous navigation. So we're going to hit Control-Shift-P, run task, Krytn navigation, and that'll stand up the Krytn navigation system. So this is a pretty cool little system. We've got this little robot here, this little blue robot called Krytn, which is a robot that I've got driving around a coffee shop in Perth City and in Australia. And so the kind of idea is this is a simulated environment of something that looks a bit like a coffee shop that you can get as part of the gazebo sort of free environments, actually. And so we've also got this other thing which we'll have started, which is called RViz. And this is a system for visualizing the robot data from the perspective of the robot. So you can imagine this gazebo sim is like the world, and this is like the robot's perception of the world. And we've already set up a simultaneous localization and mapping and a navigation system. So we're just going to play with it to get a feel about how it works. So I'm going to click the 2D goal pose and hold and click go. And what you'll see is it creates a little path here. And this path is the path that the robot's going to try to achieve as it drives around the world. And, if it runs into, if it sees obstacles or objects, or it has to avoid things it sees, it's going to change that path. And I can interrupt it at any time and give it a new path. And something that's really cool, I think, is that as we drive around, so far the paths have been pretty straightforward. But you can see here that there's a bar, there's like there's a bench. And what we're going to do is we're going to tell Krytn to drive around. And so instead of going the straightest path, it's going to try and navigate around this obstacle here. And that's pretty cool. So Krytn's able to do that, and you can see Krytn here driving around. And as it goes, you can see that it's making a better and better visualization of what its map should be. And that's really cool too. So that allows Krytn to drive around and do things autonomously. Now let's do something kind of fun and a bit terrible. So it's decided to go on this weird path here. So what I'm going to do is I'm going to put a random cube just in the way. Oh, and it's not quite in the way. I'm going to put another cube over here. That's going to make quite the obstacle. Let's see if Krytn can figure out what to do. So you see Krytn has updated its path to avoid that obstacle. But let's be a bit annoying and let's chuck another one in there. And now there's another path, and so Krytn's going to try and work out how to drive around it. It's going to keep going. It's going to see that, maybe it needs to keep going further. And so you can see that this system allows Krytn to deal with objects that just turn up in the world somewhat unexpectedly. And so that's pretty cool. And that's all I really wanted to show you today. I wanted to show you the ability of the robot operating system to set up a autonomous navigation robot that you can use and you can deploy to real robots in the world. So have a play with that. Play with putting objects in the way of Krytn, and just experiment around with this system. If you want to do it yourself, this is a great example. So you can take this as example source code for creating your own autonomous robot system, either a simulation or even porting it to the real world. So yeah. So that's all I wanted to show you today. If you're interested in, in becoming a roboticist, just, your daily reminder, you can come and join my course where we hang out and talk about all this stuff and go in really deep. But tomorrow we're going to look at robot arms and how to use another open source tool called Move It to control a robot arm and do that in a kind of a fun way. So yeah, so if you're ready to start becoming a roboticist, come and join my course. Otherwise, I'll see you tomorrow where we dive into robot arms.